have a look at the last part here. This is really a continuation of something we did similar when we're trying to determine the equations of parabolas and things like that. It's really just looking at the information that you've got and using that information, typically a point or an asymptote maybe, to then try and determine the values of our unknowns. So in this case, we know that the equation goes through the point -2, 6. So don't forget that's the x, that's the y. So if we substitute that point in, 6 is going to be equal to a over x, which is -2 plus 8. So transpose the fraction, let's take our 8 across. -2 is equal to 8 over -2 multiplied by -2. That implies then that a will equal 4. So then the equation is actually y equals 4 on x plus 8. Quick check. If I substitute -2 in there, I get 4 over -2, which is -2, plus 8, which is equal to 6, which is that. Happy days. Moving right along. Similar thing. This time we have two unknowns, but you'll notice we've been given two pieces of information. So typically sub them in and we'll end up with two equations and two unknowns. So point 1, if I substitute in the 0.27, I get 7, which is the y value, is equal to a over 2 plus k. Equation 2 is the point -1, 1, so 1 is equal to a over -1 plus k. So if we simplify a fraction, I get 7 is equal to 1/2 a plus k, and 1 is equal to negative a plus k. So clearly if I subtract those two terms, I'll eliminate k. So 7 minus 1 is 6. A half a minus a minus is a plus, so a half a plus a is 3 on 2a. K minus k is 0. So I'll end up with multiplied by 2 across. 12 is equal to 3a. A is equal to 4. So we can substitute that back into any of these. We'll use that one because it's a bit simpler. So 1 is equal to -4 plus k. So k is equal to 5. So there's our a and k values. And we could just substitute those in. So that means y is equal to a over x plus k. All right, so these two are out of our textbook. The graph which has a rule passes through those 2 points. Okay, so again, exactly the same. So there's x and y. So 0.1, 0.2. So let's substitute y is equal to 2 is equal to a times the square root of x, which is 4, minus h. There's one equation. Equation 2, 4 is equal to a times the square root of x minus h. So there's my two equations. So just to manipulate this one, I guess the square root sign is always a little bit messy. So what if we sort of try to tidy that up a bit? So if I divide by a, I get 2 over a is equal to square root of 4 minus h, which implies then that 4 over a squared is equal to 4 minus h. Yeah, if I square both sides, do the same thing, I'll get 4 over a is equal to the square root of 7 minus h. If I square both sides, I'll get 16 over a squared is equal to 7 minus h. So we've got some h's there. If we subtract one from the other, we can eliminate. Quite possibly this could be a tech active one. So let's have a look. So if I do bottom minus top, only because the numbers on the bottom are sort of bigger. So I'll end up with 16 on a squared minus 4 on a squared is equal to 7 minus 4, which is 3, minus h minus minus is a 0. So what does that leave me? It leaves me with 12 on a squared is equal to 3, multiplied by a squared. 12 is equal to 3a squared. So then divide by 3. 4 is equal to a squared. A is equal to plus or minus 2. Now, it doesn't say anything about a being positive or negative. So we can have both those answers. So if a is equal to positive 2, let's substitute that back into, say, that one will do. If a is equal to positive 2, I get 16, I will do the top one, 4 over 2 squared is equal to 4 minus h. 4 over 4 is equal to 4 minus h. H is equal to 4 minus 1, which is equal to 3. So we get a equal to 2, h equal to 3, and hopefully we can see if I substitute a equal to negative 2 here, a is negative 2, that just becomes negative 2 squared, which is still positive 4, so we get exactly the same answer. So what we're saying is that my rule then is y is equal to, what have we got? We've got plus or minus 2 times the square root of x minus 3. So the only thing that really concerns me is this sort of plus or minus here when they both generate the same value of h, which is 3. So let's have a quick look at the graph sketch. So what we've got is we've got the square root function shifted 3 units along to the right. So if I've just got the positive square root, it's that section. If I've got the negative square root, it's that section. So clearly the graph itself, it says it's got to go through the points 4, 2 and the point 7, 4, which is there. So clearly we need the positive section here. So in that case, we can restrict it or eliminate our negative option and just make it 2 root x minus 3. Okay? All right, last one. The equation of a circle whose centre is the point 1, negative 1, and which passes through the point 4, 3. So the equation of a circle, what is the equation of a circle? So it's x minus h all squared plus y minus k all squared is equal to r squared. There's my centre. X minus 1 all squared plus negative 1, so you're going to go through y plus 1 all squared is equal to some radius squared. Now to work out the radius, it goes through the point 4, 3. So let's substitute that in. X is 4 plus y is 3, and that's got to equal r squared. So what's that mean? We get 3 squared plus 4 squared is equal to r squared. So r squared is equal to 9 plus 16, which is 25. So radius is equal to plus or minus 5. Clearly the radius has to be greater than 0. So r is equal to 5. So my equation is given by, let's just highlight it, x minus, what do we say, 1 all squared plus y plus 1 all squared is equal to 5 squared. Okay, so if we have to find our equations, we just substitute in the values that we've got and then try to find them, typically using simultaneous equations or some other method.